Hello Ninja Warriors, welcome to yet another power packed session from PYQ series. As you can see that in this session we are going to cover all the PYQs from JEE Main 2024 April attempt from the chapter limits. Okay, so I have the stats of limits chapter with myself. You can clearly see that in January attempt JEE Main 2024 there were 11 questions were asked from this chapter, and from April attempt 10 questions were asked from this chapter. So approximately 10 to 11 questions you can expect in your next attempt. Okay, so what does that mean? So in January attempt there were 10 question papers, 10 shifts, and in April attempt also there were 10 question paper, or you can say 10 shifts. So in each paper it was observed that at least one question was asked from the limits chapter. And here I am only talking about limits. I'm not talking about continuity. I'm not talking about differentiability. Okay, so I guess this chapter limits is worth investing your time in. Why? Because if you understand limits very well, no, then it is very easy. You will have to spend a very little time in continuity and differentiability, and again you can easily do that question as well. So limits is actually a very good chapter. I to say must do chapter. Okay, all right, so we will start everything one by one. And if I talk about the nature of a question, nature of the questions, so I would say the variety of questions were observed. Some were easy, some were difficult, that we are going to tackle. Okay, all right, so let us start with the very first question. Okay, so I always say that the moment you see the question from the chapter limits, what do you have to do? You have to check the form of that particular limit, right? The moment you check the form of that limit, you would be able to understand that what technique or what method you have to apply in solving that question. All right, so the very first question I can see that limit extend to 1, and the expression involving radicals 1 by 3, 1 by 3, 1 by 2, 1 by 2. Okay, and this limit we have to calculate in terms of m and n. Then eventually we have to figure out the value of mn plus 12n. Okay, step by step we are going to do. You know, the very first step, check the form of that limit. Let's do that. The moment I put x equal to 1 in this whole expression 1 by 1, so form will be, this is, if I put 1, this will become 6 raised to power 1 by 3. Correct? Minus this will also become 6 raised to power 1 by 3. So it feels that 0 is getting created. So 0 by 0 form is anticipated. Let's see what is happening with denominator. So 3 plus 2, 5 raised to power half, and 1 plus 4, 5 raised to power half. So clearly 0 by 0 form is getting created. So there are multiple methods to solve 0 by 0 form. Factorization, uh, rationalization, L'Hopital also. Factorization and L'Hopital, if it fits in this method, well and good, but L'Hopital is something which I would like to apply. Let's see what happens. Although I'm not in a favor of L'Hopital at times, because usually what happens, that the moment you try to apply L'Hopital, the things will become very complicated. But there will be a few questions wherein, like this, wherein L'Hopital comes into the picture. Okay. So yes, let's apply L'Hopital. You know how to apply it. So differentiating numerator and then differentiating denominator separately. Okay, no need to apply quotient rule. So this is going to be limit x tend to 1. Now this 1 by 3, if I am differentiating, 1 by 3 will come in front. 5x plus 1, then 1 by 3 minus 1. So 1 by 3 minus 1 will become what? Tell me. That is going to be minus 2 by 3. So I need to write it directly, minus 2 by 3 over here. Yes. So minus 2 by 3. All right. Minus, again 1 by 3 will come in front, x plus 5. 1 by 3 minus 1 will become minus 2 by 3. So the numerator part differentiated nicely. Now what about denominator? 1 by 2 will come in front, 2x plus 3. Half minus 1 is minus 1 by 2. Minus 1 by 2 will come in front, x plus 4 raised to power minus 1 by 2. I know. Some of you might be like, ma'am, hold on, you have not differentiated it appropriately. How many of you noticed the mistake? I did that mistake deliberately. so that you understand that so many of you have not even noticed it as well, and some of you might be able to do it in this manner. So in chain rule, what do we do is, if I want to differentiate this now, so I have to differentiate this inside function also. 5x plus 1, if you differentiate, you will get 5. X plus 5, although if you have differentiated, you will get 1. And here you will get 2, and here you will get 1. Okay. Special attention to this. Do not make any mistake like this. All right, and now the moment you put x tend to 1, let's see, hopefully, fingers crossed, that we do not get end up 0 by 0 again. Okay, so let's do that. If I put 1 by 3, so 5 by 3 is here, and if you put 1, 6 raised to power minus 2 by 3, correct? Okay, minus, now the moment you put 1 by 3, 6 raised to power minus 2 by 3, correct? Okay, all right, now 2 by 2, that is going to be 1. The moment you put 1 over here, 5 raised to power minus half, and this is going to be 1 by 2, 5 raised to power minus half, correct? Okay, and obviously we have put, now this value will be equal to 6 raised to power minus 2 by 3. I'm going to take common from numerator, and so this is 1 dot, not 15, 1.5, and this is 5 raised to power minus 5 minus half from the denominator. So I'll be left with 5 minus 1 by 3. 5, this is 5, it is looking like 6, but it is 5. All right, 5. So 5, and this is nothing, 5 minus 1 by 3, that this is 1 minus half, correct? And because the power of 6 and power of 5 both are nothing but negative, so why not we just shift both of them towards like take reciprocal of it. So 6 raised to power 2 by 3, I'm shifting it in the denominator, and this is 5 raised to power minus half, so it will be root 5 in the numerator. Now 5 minus 1 by 3, tell me, 3 5s are 15, so 14 by 3 and 1 by 2, correct? So what we are getting over here is, now if I have to like make it in this format, so clearly this is 28 by 3 if I'm not wrong. Okay, 5 3s are 15. Let me just confirm the calculations. Have I done anything wrong? 5 3s are 15 minus 1. Oops, this is 5 by 3. Yes. So this is actually, I was doing some mistake over here. So let me do it one more time. Okay. Yes. So this is multiply 5 by 3 minus 1 by 3. Easy calculations, right? And this is 1 minus half. So you will be getting 4 by 3 by 2. 4 by 3 by 2. So finally what we are getting is 8 by 3, correct? Root 5 whole upon 6 raised to power 2 by 3. Now 6 raised to power 2 by 3 is 2 multiply 3 raised to power 2 by 3. So now it is very clear, easier to compare as well. M root 5 upon n 2n raised to power 2 by 3, correct? So m is clearly, if I compare, 8, and n is clearly, if I compare, 3. 8 comma 3 is the value, so 8 multiply 3 plus, sorry, 8 multiply 8 because m is 8 plus 12 multiply 3. 64 plus 36 is gonna give you a perfect 100. Okay, so I guess this is an alpha question. What is alpha question, by the way? Are you aware about this? So this is an alpha question. Alpha question. So I always tell you, just mindlessly you don't have to solve PYQs, right? Here is a ninja tip for the day. So there is a strategy wherein if you are giving any mock test or if you are giving any JEE main paper as well, so that strategy is that always think about getting maximum marks in first 15 minutes of the paper or first 15 minutes of any section. So suppose you are giving a JEE main mock test or main paper as well. So what you need to do is you have to scan and divide the whole section. For example, you have picked chemistry first, physics second, and maths third. Okay, so I'm talking about section wise. So if you pick chemistry, so you need to scan and divide the whole paper into three categories: alpha, beta, and gamma. Yes. So what you need to do is, in chemistry there will be 30 questions, right? So out of those 30 questions now, 20 is MCQ and 10 is numerical type, correct? Now what you have to do is you have to identify 6 to 8 questions which are of easy category, and trust me, there are 6 to 8 questions in each and every JEE Main paper which are doable. So you have to identify 6 to 8 questions which can be done in less than a minute, which will require less thinking, direct formula based, no great calculations, not a lengthy thing, okay? So 6 to 8 questions you will have to select, that is alpha category, right? So in the beginning of the section you have to spend 10-15 seconds, okay? Then you have to figure out again 6 to 8 another questions which are of beta category. Now what is beta category? Beta category is nothing but that you have to uh, identify those questions which are still doable. You can see it that yes, I am able to do it, I will be able to do it, but it might take a little bit thinking, thought process, or it is lengthy in calculation. Okay, so that is beta. And the last category is gamma category, which you think that that question is scaring you a lot and that question is not at all doable. So that is gamma category. So that you don't even just try to waste your time in those questions. Okay. So alpha and beta is very, very important. You have to identify. So in first few minutes, 15 minutes, if you pick chemistry, imagine that you are doing 6 to 8 questions smoothly, and that is less than a minute. Some questions are doable in less than 20 seconds as well. So that is alpha category. Then beta, you are like mentally prepared that I need to spend good time in the beta questions so that you don't panic, because you have completed all the easy questions, right? So this is a ninja strategy, you can call it, which will help you in mock and which will help you in JEE Main also. Okay. Now, why I always say that this strategy you cannot just develop it overnight, because this is very intuitive. In 15 seconds, you have to identify the question category, right? This is not at all a noob's job, right? So you have to train your brain right from the very beginning. So the moment you start solving PYQs, just you are like doing the PYQs, what you have to do is you have to train the strategy like this. So the moment we complete the question, we will tag that question. That is actually very, very important in this particular series. That is USP of that series. You are not even solving, you're not just solving PYQs, you are also identifying the question, and you have to think after solving last 10 seconds. You have always think, if this question arrives in JEE Main, will I be able to do it in within like 1 minute, or will I be able to do it in less than 2 minutes, or it will take more than 2 minutes? So that analysis also you have to do, right? So this is the strategy that you have to keep building, and I will help you out. Okay. So this question, tell me that how will you rate this question? I say this is alpha category because L'Hopital you have applied and the calculations are also not that tough. Okay. All right. Okay. Now let us move on to the very next question. And now fx is given as integral of 0 to x t plus sine 1 minus e raised to power x. This is calculation, printing mistake, e raised to power x dt. And limit of this x tend to 0 f of x upon x cube. Okay. So this type of question are very popular kind of question. This I have not taught you in limits chapter, but I have taught you in definite integration chapter. Yes, I will teach you, or I will teach you. Yeah. So this is a Leibniz theorem problem. Okay. So first of all, let us understand the category of this problem. There are so many problems JEE Main is asking since past few years, which combines limits plus definite integration plus Leibniz theorem. But by the way, three categories like hybrid question, but not that difficult, very easy. है ना? Again, before solving it, I am telling you this is the alpha category, right? Do not at all think of missing it. Okay. So fx, right? So first of all, let's just plug in the value of fx over here. Okay. So your expression will become limit fx. Fx is 0 to x. Then we have t plus sine of 1 minus e raised to power x. Okay, bracket close, one more bracket close, then dt. This is your numerator, and this is whole upon x cube x tend to 0. Right? This is the expression. Now tell me, I always say whenever you see limits, what do? Check form of that limit. The moment you put x equals to 0 in denominator, so the form of this limit, denominator is 0, but what about numerator? Numerator is 0 and here also 0. Upper and lower limit of the integration becomes 0. What does that mean? This is 0 by 0. When upper and lower limit becomes exactly same, then the value of that integration, definite integration, becomes 0. So 0 by 0 form. 0 by 0 form, that means we are going to apply L'Hopital. How many times? That we need to check, but L'Hopital is applicable. Derivative of x cube, that is denominator, it is very simple. But if I talk about the numerator part, can you see you have to differentiate the integration? Yes, you have to differentiate this whole thing. For that, Leibniz theorem come into picture. What is Leibniz theorem? So Leibniz theorem says, by the way, this is Newton-Leibniz theorem. Okay. All right. So Newton-Leibniz theorem say if you have to integrate any function, suppose you have to integrate any function f of t dt, right? Okay. And the upper and lower limit out of both the things, at least one should be variable. So, and the variable should be different also. So this is gx and hx. So this is the thing, and now you have to differentiate this. So the format is clear. Integral of something and the variable is different and the variable of integration is different. T is the variable of integration and the upper and lower limit is having different variable. Okay, so this is the format. Now you have to differentiate this with respect to x. Right? So how do you do that? You know, integration and derivative is anti of each other. So you don't really have to integrate anything. You don't have to differentiate as well. So there is some rule that you have to follow that I'm going to tell you. What you need to do is the derivative of this integration will become equal to now f of t. So this t, which is the argument, will be replaced by upper limit. So f of h of x. T will be replaced by upper limit. And now you have to differentiate the upper limit, h dash x. Minus. Now again, same thing. Now it's same thing but with lower limit. F of g of x and g dash x. That's it. Okay. Alright. So let us apply the same technique. This is looking a little bit difficult because hx, gx, fx, everything is there. But once you apply it in actual question, you will realize it is not that difficult. Okay. So applying L'Hopital in that, L'Hopital. So to apply L'Hopital, we need to apply Leibniz in numerator. Okay, so let's differentiate this numerator. So you know how to do that. So upper limit is x. So this thing is actually, this is t. Sorry, this is t. This is not x. This is t. Yes. So now t. Now you have to replace t by upper limit, which is x. So x plus sine of 1 minus e raised to power x, correct? And now you have to differentiate the upper limit, which is 1 minus. Now lower limit. The moment you put 0 in this expression, it will become something. And then you have to differentiate 0. So I don't have to do all that hard work because the derivative of lower limit will become 0. So it will give me nothing. The minus, after minus sign, I will get a 0. Upon, we are having 3x square, limit x tend to 0. Now can you see we are free from that integration. This is a normal general expression whose limits we are interested in. Right? So it's just as simple as that. Now one more time, this is a brand new question. Identify it as brand new question. X tend to 0, the moment you put 0 over here, you will get 0. The moment you put x equals to 0 over here, you will get e raised to power 0, that is 1. Again, 0 by 0 form is getting formed again. So L'Hopital one more time. So 1 plus sine 1 minus e raised to power x, and if I differentiate, because chain rule, no? So I have to differentiate this one more time. So minus e raised to power x upon 6x. Limit x tend to 0. Okay, alright. Now limit x tend to 0, and one more time if you differentiate, so what you're going to get, this is together. 1 ka to 0 plus sine ka derivative is cos of 1 minus e raised to power x. Now one more time you have to differentiate this part. So minus e raised to power x one more time. So this is e raised to power x square upon 6. Now you are done. Now you just have to put the value. X ko the moment you put 0, 0 plus cos of, again cos of 1 minus 1, 0, and e raised to power 0 ka square upon 6. Clearly cos 0 is 1, e raised to power 0 is also 1. So 1 by 6 is absolutely right. Option D is absolutely on point. Okay. So I would say again, alpha question. Okay, alpha little bit higher on the side of alpha, but yeah, alpha, because if you're doing for the very first time, you might feel that it is taking a lot of thinking, but this is a same category. You solve 4-5 questions and you're like, now I know, at least I know the algorithm. There is no multiple calculations involved. Let's see what is next in our plate. All right, so let f be a differentiable function such that f of 1 is equals to 1. All right. And now limit t tends to x. And t square fx minus x square f of t upon t minus. Okay. So this expression is given to us. And we need to figure out 2f of 2 plus 3f of 3. So basically what we need to figure out is f of x. This is what we need to figure out. Okay. So first of all, again, the moment you see this, like limit is having some variable quantity, always go for L'Hopital. And obviously you have to check the form. The moment you put t is equals to x in this expression, you will get again 0 by 0 form. Okay. So let us just start doing that. So let us start applying L'Hopital. But can you see there are two variables over here? So do not get confused. L'Hopital is only applicable wherein the first, like t tends to something. So x over here will be treated as constant and t will be the variable. So L'Hopital I am applying, and here t will be the variable. Correct? So this is going to be limit t tends to x. Now t square fx, derivative of that would be 2t f of x minus x square is again constant, f of t will be f dash t. So now you know exactly what we want to differentiate, t minus x. So t will be differentiated as 1, x will be treated as constant. T variable and x is constant. Okay, all right. Yes, now what we need to do is we just need to plug in, because 0 by 0 form is vanished. The moment you feel that 0 by 0 form is gone, because can you see the new denominator is 1. So you start putting that t tends to what? T is equals to x. You put. So now you are going to get the value of limit 2x f of x minus x square f dash x, that is going to become 1. This is your expression. And from this only you are going to get your f of x. Now, actually, this is the question of limits plus differential equation, my dear students. Yes. So differential equations, maybe you have not studied differential equation, but if you study differential equation, then come back to this question and understand from here. Okay. So in differential equation, what I'm going to do is I'm going to put f of x equals to y and f dash x equals to dy by dx. Then only you will be able to see. Right now you won't be able to see. So 2xy minus x square, 2x, fx is y minus x square f dash x is dy by dx, and that is 1. So let us properly arrange it, okay? So what I'm going to do is 2y minus 1 is equals to x square dy by dx. I need to identify form of this particular differential equation. So dy by dx is equals to 2xy minus 1 upon x square upon x square. Alright. And actually, this has to be on the left hand side because I can clearly see that linear differential equation is getting formed. So 2 by x into y is equals to minus 1 upon x square. Can you see this is linear differential equation? Let me just tell you the exact form of standard form of linear differential equation. dy by dx plus py equals to q is your LDE. How do you solve this LDE? Let me just tell you. Let me just give you the glimpse. The moment you see this form, na, so you don't have to solve it. You just have to apply the standard technique to solve LDE. How to solve LDE? So here I'll be telling how to solve LDE. How to solve LDE, and here I'll be solving. Okay? So first thing is you have to calculate integrating factor. Let's calculate integrating factor. Okay? That is going to be e raised to power integral of p dx. Okay, this is your integrating factor. So you have to calculate it. Once you are done with that, final answer you have to write. You don't have to like solve it. Final answer you have to write. Y multiplying integrating factor is equals to integral of q multiplying integrating factor dx plus c. That's it. You're done. Now again, we are going to apply the same thing in this. Integrating factor of this differential equation will be what? Tell me. E raised to power integral of minus 2 by x dx. Correct? So this is going to be e raised to power minus 2. If I take common, 1 by x dx ka integration is log x. So this is actually log x raised to power minus 2. This is e raised to power. And this is finally going to become x raised to power minus 2. So your integrating factor is what? 1 by x square. Okay. Now let us solve the this equation. How do you solve? You just have to put the value of integrating factor in this equation. So y upon x square is equals to q times. What is q? This is your q. So minus 1 upon x square into integrating factor dx plus c. So you have to integrate this. So y upon x square equals to integral of x raised to power minus 4 dx plus c. So this is minus 4 plus 1. So minus of e raised to x raised to power minus 4 plus 1 is minus 3 upon minus 3 plus c y upon x square. Let us rearrange it, right? So this is going to be y equals to, if I multiply x square on the right hand side, that is 1 upon 3x plus cx square. All right. This is your y, which is nothing but f of x. So can I just write it, replace f of x is nothing but 1 upon 3x plus cx square. Correct? And in the question, let me just go back to the question. F of 1 is given as 1, right? So using this 1 comma 1, I can actually identify this constant c value so that proper fx I can calculate, right? Without even constant. F of 1 is equals to 1 by 3 plus c. And if I put 1 over here, 1 by 3 plus c. So c is actually coming out as 2 by 3. And now you are having f of x, which is 1 by 3x plus 2 by 3x square. This is your fx. Now you calculate whatever you want to. What do you want to calculate? Tell me. 2f of 2, 3f of 3, right? So yes, very easy. 2 times f of 2 plus 3f of 3 equals to 2 times f of 2. So 1 by 3 to the 6 plus, so this is 2 square, so 8 by 3 plus 3 times f of 3, so 1 by 9 plus 9 9 is 81, so 2 by 3 into 81. That's it. Done, done, done. Let's just start solving it. So the moment I multiply 2 inside this, so I'm going to get 1 by 3 plus 8 by 16 by 3. right? 1 by 3 plus 16 by 3 plus. Now if I multiply 3, so 1 by 3 plus 3 cancels. So that is going to be, oh, if I do not even cancel 3. So 3 cancel, 2 by 3 into 81. 3 to the 6 into 81 by 3. Let's take LCM. Finally, you are going to get 17 by 3 plus 1 plus 81 into 6. 6 ones are 6, 8 6 are 48. 486 by 3. So finally, 18 plus 486 by 3. ठीक है, 3 6 are 3 ones are 3, 3 6 are 18 and 3 2 are. So 162 plus 6 is 168. So what is the final answer of this question? 168. Chalo, let's move on to the next problem, my dear students. All right. Now this question. This is a little, I won't call it at all alpha. This is either beta or some of you might feel beta plus. Okay. But the concept part is actually very good. I will say a very good question. Let us understand. There are a few things, hidden things in this question. So please understand this question very, very nicely with your maximum attention. Let a greater than 0 be a root of this equation 2x square plus x minus 2. Okay. And if limit x tend to 1 by a, okay, x tend to 1 by a of this expression, which is having a quadratic expression over here. If I try to match this expression, it looks similar, but it is not exactly the same. You have to be very careful about it. 2x square plus x minus 2, can you see? There is some sign change over here. Okay. All right. So I am going to write the expression, rewrite this expression over here. So this is limit x tend to 1 by a. 16 is already here. 1 minus cos. Now 2 plus x minus 2x square, you know that cos of minus x is equals to cos x. So let's make use of it because I want to make this quadratic with a positive leading coefficient. So this is going to become 2x square minus x minus 2. Did you notice these two expressions are very different? They are looking similar, but they are not similar in reality. Okay, and bracket close, and this is 1 minus ax square. I want, okay, let us keep it as it is right now. And let us just find out how to, like, what is the commonality between this and this 2x square minus x by 2. So this roots of this expression, let us say a and b, because a is already given to you. One more root I have assumed b. Now we can clearly see that if I just replace x by 1 by x, because the hint is already given, can you see? X is 1 by a, right? So root of this expression is a, so I need to find an equation whose root is 1 by a, right? So x ko 1 by x, if I replace, what do I get? 2 by x square plus 1 by x minus 2 equals to 0. If I take LCM, then 2 plus x and this is minus 2x square equals to 0, or if I want to multiply it with positive sign, 2x square minus x minus 2 equals to 0, and this will have roots 1 by a and 1 by b. Or rather, one more interesting thing, I can write this expression 2x square minus x minus 2, because you know the roots of this expression, as twice of, because 2 if you take common, then only x minus 1 by a, x minus 1 by b, because leading coefficient is 2. So you need to match the leading coefficient also. Okay. So what I'm gonna do is, now you know that I'm going to write this expression, in fact this expression. So this quadratic now will be changed like this. Okay. All right. Let's do that. So 16, 1 minus cos. Then there is a quadratic expression which I am changing. And let me just write it with another color, 2. Then this is x minus 1 by a x minus 1 by b. Bracket close, whole upon, there is, if I go back, 1 minus ax square. I am trying to take common something. If I take a square common, it will make more sense. Let's take a common, so it will become a square. So it will become what? Tell me. 1 by a minus x. So this is 1 by a minus x whole square. Limit x tend to, tell me, a, 1 by a. Okay. Now one more correction I would like to do, which is a harmless thing. Can I just write x minus 1 by a instead of x minus 1 by a instead of 1 by a minus x? So x minus 1 by a. Anyway, there is a square over here. Why am I doing that? What is the agenda of this particular thing? Remember, I always told you whenever I teach limit, you go and find any session of mine. The moment I teach standard limits, I tell you that this is my favorite limit. 1 minus cos x upon x square is half when limit is tending towards 0. X is tending towards 0. This is my favorite limit, okay? So I'm trying to create that limit so that I can put half in place of it, okay? So now can you see 1 minus cos 2? So what is there? This I'm trying to create this, actually square of this in the denominator. So 1 minus cos something upon square of that something, and that something should obviously be 0, right? So the moment I put x tend to 1 by a, so this box, yellow box will anyway becoming 0. So I need a square of it in the denominator. So I can see that square of this quantity is already there, right? I need square of x minus 1 by b as well, right? So if I am dividing something, if I'm like introducing some factor, I need to compensate in numerator as well, and I need 2 square as well. So 2 square. Now what I'm going to do is I'm going to directly write half in place of what all things, just tell me. In place of this blue box, this blue box, this blue box, and this blue box, because it is exactly 16. I'm just writing it aside upon a square, okay, and rest everything is 1 by 2, that using this limit. And now we are having x minus 1 by b whole square, okay, and 2 square. And no need to write x also, because we are just putting the limit. We are finally calculating the value of that limit. So x will be replaced by 1 by a. So this is 1 by a minus 1 by b. So this is actually going to become 8. 8 fours are 32 by a square. 1 upon a minus 1 upon b square. Now let us just keep it over here. Why I am saying this? Because we need a and b over here. Okay. All right. Yes. So from here, what I'm going to do is 1. So what do you need exactly? You need the value of a, and you need a minus, okay, let us see what we can extract from. So this is the original. Either you just pick original, and a and b are the roots. So you know that product of roots is what? Minus 2 upon 2. That is minus 1. Okay, this is product of roots. And okay, sum of roots, tell me. So sum of roots, a plus b is nothing but minus 1 by 2, correct? And from here also, like first thing, second thing, third thing, if I calculate roots of both the equations, what do I get? Because I need a separate value of a also. So a will be equals to, so clearly it is written a is a positive value. A will be 1 minus 1 plus square root of 1. Okay, let me calculate. So 1 plus 4ac. So 4 2s are 8, 8 2s are 16 by 2. So a is actually coming out as root 17 minus 1 by 2. And b is coming out as minus root 17 minus 1 by 2. Right? Maybe you're not able to see it. Okay, B is, so let me just write it on the next page. Okay, so what we are getting is AB is -1 and A plus B is equals to what? -1/2, and A comma B is equals to what? -1 plus minus √17 by 2 times A. Sorry. So 2 times 2 to the 4. So this is 4 over here. 4 upon 4. Correct. Now we are done. We just have to plug in the values. Calculated all the details. Alright, so 32 upon A square. Now AB and A minus B whole square. So AB is -1. -1 ka whole square will be 1. So 32 upon A square. This AB is -1 ka square anyway 1. A minus B whole square. So now 32 A minus B whole square will be what? A plus B whole square minus 4AB. Can I write it this way? Yes. So 32, and now upon A square, let's not forget, A plus B value is what? -1/2. So 1/4 minus 4AB. So plus 4. That's it you are having. So this is 4 for the 16, 17, 32 into 17 upon 4A square. 4 8s. So this is 18 into 7, 8 into 17 upon A square. Correct? And now if I just use this because I don't want this square roots in the denominator, then I have to rationalize it. That is also a method, but I don't want to waste my time. So the smart move is AB is equals to -1. So tell me, A is equals to -1 by B. A square will be 1 by B square, correct? So 1 by A square is equals to B square. So why not make use of it? So this is actually 17 into 8 and there is B square. 17 into 8. So let me just write 17 into 8 into B square. 17 into 8. B square is what? Square of this negative root. A is positive, B is negative. So -1 minus √17 by 4. That's it. You have to solve it out. That's it. You are done. 17 into 8. Now negative square. So this both will become positive. Square is already there. 4 ka square is 16. And now we are having 1 plus √17 ka square. 1 square, √17 square plus 2 √17. That's it. So now you are left with 17. So this is 8 and 2. 17 by 2. 18 plus 2 √17. Now if you again divide it by 2, 17, 9 plus √17. 17 into 9, 7 9s are 63. 9 ones 153 plus 17 √17 is the final answer of this expression. And now this expression is alpha plus beta √17. So we are very close. Alpha plus beta √17. So if you compare, alpha will be 153 and beta will be 17. And what they are asking you is the value of alpha plus beta. So that is going to give you 0. 170 is the correct answer of this question. So that's why in the beginning only I told you that yeah, there are some steps required. This is not absolutely non-doable question, but definitely a doable beta. All right. Yes. Chalo. Now we are having another question on our plate. Let's see what this question has to offer. All right. Let me just check. Yeah, let me drink some water. All right, again, another thoughtful question. All right, so one thing in this question is that you have to understand to get the drill of it, and then the question is very easy. Just one thing. If you understand, if that one thing strikes in your brain now, then you will be like, you're going to kill this question. Okay. So they are saying that there is a function, differentiable function, which says that f-1 is this. Okay, so you need to understand any expression of the type limit a tend to infinity a square into a function of a, sorry, 1 by a. That you can directly write f-1. Okay. All right. And now they are giving this value. So you need to actually establish a connection between these two things. That's it. If you are able to do that, then this question is actually an alpha question for you. Okay. Just that thing. Okay. All right. So now what we are going to do is we are actually trying to form this thing in this expression. So for that, I need to take a square away from this. Let's take a square common. So limit a tend to infinity. If I take a square common, what do I get? Tell me. So this is already a square plus a. This is what? A square plus a. 1 by 2 is already there. 1 by 2 if I take common. A square plus a. I am taking a square common from each and everything. A square if you take common, you will get 1 plus 1 by a. Correct? Then tan inverse 1 by a is already there. Plus if I'm taking a square common, this will become 1 minus, this is not having a square. So I have to divide it by a square and ln a. Is that fine? Is that correct? Is that okay? Yes. Limit a tend to infinity and this. Now a square into f of 1 by a. So I need to make sure that this bracket is having everything in terms of what? This bracket should have everything in terms of what? Tell me. 1 by a. Are we ready for it? Okay. So limit a tend to infinity. A square is already outside. Now my focus is to create 1 by a everywhere. I can't see a anywhere. So yes, till now it is going fine. Everywhere 1 by a, 1 by a. Okay. Either constant or what, but what about this? ln a. So yes, ln a is nothing but minus log of 1 by a. Can I write it this way using the property? Because what I'm doing is basically minus 1 power minus 1 I'm doing. This minus 1 power I'm taking outside, which is this minus 1, and a raised to power minus 1 is ln 1 by a. That's it. Okay. And this is limit a tend to infinity a square and 1 by 2. This is 1 plus 1 by a. Tan inverse 1 by a plus, oops, यहाँ पे yes, what I was doing is, this is, sorry, why I started writing again, this is log of 1 by a, that's it, plus sign log of 1 by a. Now, what I'm gonna do is, yes, the next step is very critical. So basically what you are trying to do is, you have just created same form. So this expression is nothing but f of 1 by a. This is your f of 1 by a, right? Okay. So by looking at this now, what you can do is you can write your f of x now. Now is the time you identify your f of x. If this is your, tell me, if this is your f of 1 by a, so what you will do is 1 by a, if you replace it with x now, then it will become f of x, yes or no? And obviously this limit value is nothing but f dash 1, because you are able to create this in form of a square, limit a square f of 1 by a right in front of you. So this limit will be equals to f dash 1. Now what you need to figure out is value of this limit. So that is f dash 1. So f dash 1 is what you're looking for. For that you have to figure out what? fx. fx we are writing now. How come we are writing? By using this. Just replace 1 by a by x everywhere. So f of x, tell me. 1 by 2, ma'am. This a square you have to like keep it aside. 1 by 1 plus x tan inverse x plus 1 plus 2 into x square, right? Because 2 by x square, 2 by a square, so 1 by a replaced by x, so 2x square. Okay, so 2x square and log x. 2x square and log x. This is your fx. Now f dash x, very easy. Okay, and this value, we are very close to your answer. 1 by 2. 1 plus x is constant. Derivative of tan inverse x is what? 1 upon 1 plus x square. Plus 1 by 2, this time tan inverse x is constant and derivative of this is 1. Plus, again chain rule, product rule. 2x square ln x, you know how to differentiate. 2x square, derivative of ln x is 1 by x plus, This time ln x is constant and derivative of 2x square is 4x. Alright. Now what you need to do is you put x equals to 1 and you are done. So 1 by 2. The moment you put 1 over here, 1 plus 1, 2, 1 plus 1, 2, 2 by 2. So this is 1 plus 1 by 2. You put tan inverse 1. Tan inverse 1 is pi by 4. Correct. Plus, this is x cancel 2 into 1 plus 2. The moment you put x equals to 1 over here, this will give you 0. So finally, what you're getting, 2 plus half is 5 by 2 plus pi by 8 is absolutely correct answer of option D. So what was the overall drill of this question, or what is the main step? So the main step is that you have to establish the fact that they are giving something to us, which is not too direct, right? And they are giving another form. So limit a tend to infinity, some other form is given, limit a tend to infinity, similar type of form is given to you. So what you need to do is you need to use this form to create this form, and then you need to identify your f of a. Once you are done with f of 1 by a, so f of 1 by a is clear. Now you replace 1 by a by x, so to get f of x, and identify this also. If this you are writing na limit a tend to infinity a square f of 1 by a, so make sure that they are only giving na this is f dash 1. So actually this is a loop question. Using this to get this, using this to get that. Okay, so this is the type of question, beta, alpha. It is somewhere between alpha and beta. More towards beta, I would say. Okay, all right. Another question on your plate, which is the form of this question is infinity by infinity. Okay, this is clearly visible. And there is one shortcut in infinity by infinity. I have already told you. Let me just tell you. Let me just give you that concept. The moment you see limit x tend to infinity, let's say x square plus 2 upon 3x square plus x plus 1. Okay, this kind of question. So here, if the degree of numerator and denominator becomes equal, the highest degree. Upar also denominator is also 2, numerator is also 2. So what is the correct answer? Let's keep it 2. What is the correct answer of this question? You don't have to solve it. Just write 2 by 3. Highest power coefficient of numerator is 2. Highest power of denominator coefficient is 3. 2 by 3 will be the correct answer. If you know this question will be a cakewalk for you. Okay. First of all, I can see that this is a proper summation going on in the numerator and in denominator. So let me write the general term out of it. Okay. So this is actually r square minus r. Can you identify r square minus r? R square minus r. So r square minus r, general term. And this is n minus 1, n minus 2. So this is n minus r. Sigma r is starting from 1 to the last term will be n upon. Again 1 cube plus 2 cube. So this is actually sigma r cube minus sigma r square. Denominator is pretty simple. Limit n tend to infinity. So individually we have to figure out the value of sigma in the numerator and then denominator. Then we can do some cancellation if at all they are there. Let's do that. So first of all, this we have to multiply. Let's do that. So this is n r square. So n times sigma r square. This multiply this. Then minus sigma r cube. Then we have minus n times sigma r plus sigma r square upon sigma r cube minus sigma r square. Okay. All righto. Clear? So limit n tend to infinity. N times. Now you can just right away put all the sigmas. You know, sigma r, where sigma is operating from 1 to n. Sigma r is what? n plus 1 by 2. Sigma r square is what? n plus 1, 2n plus 1 by 6. Sigma r cube is n plus 1, 2n plus, sorry. Sigma r cube is n plus 1 by 2 ka whole square. Flow mein I was writing upon 2. Yeah, these are the three formulas that you have to use. Okay. So let's do that. N times sigma r square. So the second formula we are using, n plus 1 2n plus 1 by 6 minus sigma r cube, which is this. So this is square. Sorry. n plus 1 by 2 whole square. So this is sigma r cube is n plus 1 by 2 ka whole square minus n times this is sigma r. So that is n plus 1 by 2 and plus sigma r square one more time. So n plus 1 2n plus 1 by 6. Correct? है ना? Whole upon big expression, I can see that. Sigma r cube. So this is n plus 1 by 2 whole square minus sigma r square n plus 1 2n plus 1 by 6. Now you have to gauge infinity by infinity form. What is the highest power of numerator? The very first expression is giving me what? 4n together. So degree 4. So very first expression is having degree 4. Second expression is also having degree 4. Third is having degree 3. So I'm not interested in that. This is also having degree 3. Not interested. I guess the highest power from the numerator is degree 4. What about denominator? So this is again degree 4, but this is degree 3. I'm not interested in that because I'm looking for coefficient of highest power. Okay. So from here, if you multiply the highest power only n, 2n by 6. So what you're getting is 2n raised to power 4 by 6 will be the highest power term. N raised to power 4 ka coefficient is 2 by 6. No need to open everything. Minus. From here also you're getting n raised to power 4. So you need ever to extract the overall coefficient of n raised to power 4. So coefficient of n raised to power 4 from numerator. So that is going to be n into n. So n square by 4. Sorry, n square by 2 whole square. Can you see n into n square by 2. So n square by 2 whole square. So n square by 4. So 1 by 4. Same, this is also same 1 by 4. This is your final answer. That's it. Okay, this is a shortcut. So this is 1, this is 3. 1 by 3 minus 1 by 4 is 1 by 12. And this is 1 by 4. So 4 by 12 is 1 by 3. Do I need to say option B is right? Absolutely right. Okay. Chalo. So tell me, this looks like a beta question. It looks like a beta question. I will also say, if I were at your place now, I would have also done that. I will do that in second pass. Like I will mark it as beta, but I will do that. But the moment I start doing that, sometimes it happens. The question looks bigger. You don't know that after solving it, then you only know na, that okay, this was beta or alpha. But like 90% you are like on the right track. 1 or 2 question you can just miss out. But this is a beta question. But if you solve it while doing all the beta questions together, then you are going to save your time. So this will actually be very good strategy. All right, another question. This looks a little bit complicated, and here I am going to use two concepts. Let me just list those concepts. One concept is expansion. Expansion of cos x is 1 minus x square by 2 factorial plus x raised to power 4 by 4 factorial and so on. Second is binomial expansion I'm going to use. 1 plus x raised to power n is 1 plus nx plus n minus 1 by 2 factorial x square and so on. Mostly this is something which you have to remember. 1 plus x raised to power n can be approximated by 1 plus nx. Okay. Alright. So limit x tend to 0. 2. 1 minus cos. Acha. So now we are going to apply the every time cos you see. So you have to apply expansion. So you can see cos x multiply root cos 2x multiply cube root of cos 3x and there are 10 terms. So you have to apply 10 expansions. 2, 1 minus. Now cos x. Cos x will be 1 minus x square by 2 factorial. No need to go so much right now. Just dot 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 will help. Multiply 1 minus 2x whole square by 2 factorial and dot 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 power half. 1 minus 3x का square upon 3 factorial power 1 by 3, and this will go all the way up to 1 minus 10x का power square 2 factorial power 1 by 10 upon x square. Okay. Now we need to do some analyzing over here before even jumping to the final thing. So I have already told you in terms of expansion, so many students ask me that, ma'am, okay, but where exactly we have to like expand, because there are infinite terms in any expansion, to where shall we stop? So you have to only think about this power x square, which is there in the denominator. So this time x square. So only you have to think about the power of x square in the numerator. Okay. So 2 is already there. Now bracket. Now tell me one thing. 1 minus multiplication of 10 brackets. Can you just see? This is not plus. This is dot dot dot. Huh. Can you just see there are multiplication of 10 brackets? And you are not able to multiply because of this radicals. 1 by 2, 1 by 3, 1 by 4 and 1 by 10. So first of all, fix this 1 by 2. So now in this expansion, right from the second expansion, I will use this thing. This n will come in front. It will jump and it will sit right next to your x. So this half will jump and it will be right here. This 1 by 3 will make a jump and it will sit over here. Are you able to visualize it? Okay, so that let's get rid of this half 1 by 3. So that I can think about the multiplication of all the brackets. So this is going to be 1 minus x square by 2 factorial. Okay. Obviously there are more terms, but we are going to ignore it right now. 1 minus, now this is, tell me what is this? 4x square by 2 and 1 by 2. 4x square by 2 and 1 by 2 is already there. Now we are going to ignore the next terms. 1 minus, if 1 by 3, so 9x square. 9, this is 9x square by 3 and this is 3 to the 6. And the last will be 1 minus 1 by 10 or 100x square by 2 factorial. So this is 2 factorial, right? Sorry. This is not 3 factorial. Every time the second term is having 2 factorial. Yes. So 2 factorial here, 2 factorial here. And this is again 2. And we are done. Okay. So now it is very easy multiplication of, can you now see 10 brackets? Okay. Upon x square. Now limit x tend to 0. This step will give you your final answer. 2 is already outside. So this, yeah, 2 is already outside. 1 minus. Now here we are going to multiply all the 10 brackets. But we are not interested in each and every term. We are interested in only 2 terms. What are those terms? First, the constant which we are going to obtain by multiplication of these 10 terms, and the coefficient of x square, or all the terms which are having x square, that we are interested in. Okay. So if I multiply this 1 with the next bracket 1, okay, and the next bracket 1, so all the ones are getting multiplied. So the only constant I am having is 1, where all the 10 brackets are listed and every one is getting multiplied with other one. Okay, so the 1 we are getting. Now minus x square ka coefficient you are looking for. How will you get x square? How on the earth you are going to get x square? Tell me. X square you are going to get once you just multiply this x square. So if you pick this bracket, so what you have to do is you have to pick a term from each bracket. That's it. And you have to multiply all those 10 terms. Okay. So from the very first bracket, I am picking x square by 2. Now from the next bracket, I can't pick this, because if I multiply these 2 terms together, no, I will get x raised to power 4. I am not interested in that. I am interested in x raised to power 2. And all the x raised to power 2 I am interested in. Okay. So x raised to power 2 is this. So if I pick x square by 2 factorial from the very first bracket, what I'm going to get is, I am going to get, so this is, I am going to multiply this with 1 of each and every. So I am picking 1 from this second bracket, 1 from third bracket. So basically x square by 2 factorial is getting multiplied with one of other brackets. So what I'm going to get is just 1 by 2 factorial. Okay. And this is going to be a, okay, negative sign. है ना, 1 by 2 factorial or 1 by 2. Now next what we are going to do is from the second bracket I am going to pick this, which is what? 1x square. The coefficient of x square is 1, and other brackets I am going to pick 1, 1, 1 each. So this is actually 1, or you can call it as 2 by 2 also. From the third bracket, can you see 3 by 2? So from third bracket, now I am picking 3 by 2, and from first, second, fourth, rest everything I am going to pick 1. So now can you see 3 by 2, all the, so this is how you are going to get all the coefficient of x squares, all the terms of x square. And this is how it is going to be upon x square. Now you just multiply 1 and 1 cancel, right? And minus minus plus x square, plus x square, x. So this is going to be x square by x square, which is cancelling out. So you are left with this, है ना? And a 2 also, right here 2 also you can see. So 2 multiply 1 by 2. Okay, let me do it on the next slide, है ना? 2 multiply 1 by 2 plus 2 by 2 and all the way up to 10 by 2. So this is 2 to cancel. So 1 plus 10. First 10 natural number sum. So that is 10 into 11 by 2. So this is going to become 55. So the final answer of this question is 55, my dear students. Okay. Good question. What do you think? Now we are having next question on our screen. Okay. Chalo. Let's understand how to tackle this question. So the similar type of question was asked in JEE Main 2021 as well. And now similar, and now they are asking in 2024. Similar. Let's see what is the similarity. So they are giving alpha and beta, which you can get only if you solve these two different limits. And alpha and beta are the roots of the quadratic equation this, and you're looking for this. So basically the question is all about getting two different limits, alpha and beta. Okay, very easy, not very difficult. This is an alpha question. Okay, this is an alpha question, I would say. Okay, they tried to make it difficult by introducing two different limits, but both the limits are not at all difficult to solve if you know the very basics of all the types of limit. So this type of question I have taken in my rower series as well, wherein e raised to power root tan x minus e raised to power root x, right? So whenever you see two exponentials together, it is always recommended that you take one exponential out, one exponential common, and mostly it is second exponential, but it is not hard and fast. Just think that which one is easier to take common. So obviously e raised to power root x, if you take common now, then it will make more sense. Okay, so e raised to power root x I am taking common. Okay, so if e raised to power root x I am taking common, so this will become minus 1. What about this? This will become, now be careful, e raised to power root tan x minus root x. Yes or no? Tell me. Because do the reverse thing. Now you multiply this. If you multiply this and this expression, what will you get? E raised to power root tan x, right? So whenever you want to take common, suppose a raised to power 6. If I want to take a raised to power 8 common from it, how do I do that? A raised to power take, if I have to take common, this is a raised to power 6 minus 8. This is how we take common. So this is a raised to power 8, a raised to power minus 2, finally a raised to power 6. This is the logic, okay? So that's how we take common in exponent. Upon we are having root tan x minus root x. Now you understood that what we are going to do? We are going to use the standard limit in this. What is that? E raised to power 0 minus 1 upon same 0 will give you 1. And it is very well created. E raised to power this upon same this, and that is 0 only. So it is actually 1. You put 0 plus in here, what will you get is e raised to power 0 is 1. So alpha is actually coming out as 1. Easy peasy lemon squeezy, right? Now what about beta? I always say that always check form of this limit. So this limit was 0 by 0. That's why we did apply this technique. This limit is 1 raised to power infinity. Can you check it out? X tend to 0. If you put 0, this will be gone. So 1 plus 0 ki power. 1 by cot 0. Cot 0 is what? 1 upon 0. That is infinity, right? So how do you tackle e raised to power infinity form? Tell me, tell me. So that is going to be tackled by e raised to power. This power will come in front. So 1 by 2 cot x. And you need to subtract 1 from the base, which is 1 plus sin x. So 1 plus sin x minus 1. Correct? So beta will be equals to e raised to power 1 by 2. Now cot x is something which we are not interested in. Why? Because we know tan x by x is 1. No? So why not write tan x right away? And 1 and 1 are getting cancelled out. So this is sin x. Obviously, sin x ko bhi there is need of x. Tan x ko bhi there is need of x. So x and tan x. Sin x by x is 1. Tan x by x is. This is e raised to power half or root e. So alpha is 1. Beta is root e. Alpha is 1. Beta is root e. And these two are equations, roots of equations. So why don't we do one thing? We just form the quadratic out of these two roots. What is the formula? X square minus sum of the roots plus product of roots. So x square minus alpha plus beta x plus alpha beta. Correct? So x square minus 1 plus root e x plus root e equals to 0. This is my quadratic. And now this is their quadratic, which is ax square plus bx minus root e. Ax square plus bx minus root e. Okay. So right now, there are two options. Either you compare these two equations or you just multiply minus sign in that. So multiplying minus sign will give you the comparison equation because this is root e, there is minus root e mismatch. So minus x square plus 1 plus root e x minus root e equals to 0. Clearly a is minus 1 and b is 1 plus root e. Okay, and root minus root e. So a and b are clearly visible to us. And now they are talking about 12 ln a plus b. So 12 ln a plus b. 12 ln a plus b is minus 1 plus 1 plus root e. 1 and minus 1 is getting cancelled out. 12 log root e. So e raised to power half. So 12 into half into log e. Log e is 1 and this is 6. 6 is the final answer of this particular question. Bingo, 6 is correct. Alpha question. Yes. And if you know the technique, then this question was definitely an alpha question. All right. Are we ready for the next question? And the next question is again from the similar thing which we did just in the beginning in this session. What was that about? That was about L'Hopital and Leibniz theorem. Are you able to recognize the type now? Yes, because you can see there is an integration symbol over here in the numerator and this is x cube. There is one variable involved over here. Okay, this is pi by 2 whole cube, which is a constant, but the lower limit is variable. So this, and now if you first of all check the form, the moment you put x tend to pi by 2, the denominator will become 0. And if you put pi by 2 over here in place of x, again the same type of thing is happening. The upper and lower limit are becoming same, which will lead this integration to 0. 0 by 0. Done. Okay. So yes, 0 by 0 form. So let's apply L'Hopital. Applying L'Hopital in the denominator is very easy. So applying L'Hopital and Leibniz theorem in the numerator. So applying this. So 2 will come in front, x minus pi by 2. Correct? Limit x tend to pi by 2. Right? And now in the numerator, remember Leibniz theorem, how we tackle that? So first of all, we need to replace the t by upper limit Okay, that we are going to do it right away. And we need to differentiate the upper limit. So pi by 2 cube derivative will be 0, constant है, minus. So we don't have to perform this. Minus. Now, the lower limit. So we need to replace t by x cube. Let's do that and differentiate the lower limit. So let's do that. Because this is variable, this will not give me a 0. The differentiation of lower limit will not give me 0. So sine, okay, 2 t. So t is nothing but x cube raised to power 1 by 3. Sine 2 x cube raised to power 1 by 3. So I have replaced t by x cube. That's it. Plus again same thing, cos of x cube raised to power 1 by 3. And now let's not forget differentiate the lower limit. So x cube ka derivative is 3x square. Okay. Finally limit x tend to pi by 2 and this is minus of sine 2x plus cos x 3x square 2 times x minus pi by 2. Okay. Limit x tend to pi by 2. Okay. Sine 2x. Now this sine 2x is nothing but 2 sine x cos x plus cos x, okay, 3x square upon 2x minus pi by 2. Now I know that we can just apply L'Hopital over here, but L'Hopital application will make things worst because we need to apply the product rule. That we are not going to do that. Okay. And if I put pi by 2 right away, denominator is still 0. And exactly what is making 0? Just tell me. Sine pi by 2 is not a trouble. This cos x is a trouble. 3x square is also not a trouble because x is tending towards pi by 2. So what I'm going to do is I am going to take this pi by this thing common. Limit x tend to pi by 2. And I'm going to take minus 3x square is not a trouble. So minus cos x I am taking common upon x minus pi by 2 because this is giving me 0 by 0 form. Rest, what is pending? So 2 sin x plus 1 3x square upon 2. This portion, the right portion, is not a trouble for us. Okay. If you put pi by 2 in this portion, what are you getting? Tell me. If you put pi by 2 over here, so I am going to get 2 into sine pi by 2 is 1 plus 1 upon 2 and 3 pi by 2 square. Pi square by 4. Correct? So that is 3 3s are 9 pi square by 8. This thing is giving me 9 pi. So this box is 9 pi square by 8. So we just need to handle this 0 by 0. Okay. So this 0 by 0. How to do that? Either you can apply L'Hopital also here, but it is not recommended. But what you can do is minus cos x, you can convert in terms of sin x. So sine, tell me, sine x minus pi by 2. Tell me, sine x minus pi by 2 upon x minus pi by 2. Just tell me this. This is sine x tend to pi by 2. So ma'am, sine x minus pi by 2 is nothing actually. Sine x minus pi by 2, if you calculate, this is sine of minus of pi by 2 minus x. This is minus of sine pi by 2 minus x. This is minus cos x. So minus cos x is written down as this only. And this is coming out as 1. So finally, you are getting 1 multiply 9 pi square by 8. That is your correct answer. Option B is absolutely right. Okay. All right. So I guess that till here, that if you are onboarded with this thing, that Leibniz plus L'Hopital, I guess you will be able to pull off till here. Okay. And after that, even if you apply the L'Hopital thing, no, then also it will work for this question. But I will not recommend because you can't do that. Like half question you are applying L'Hopital, half not. Okay, but yes, then you just have to apply the common sense that cos is not having, or you can just the other thing is you can just put x equals to pi by 2 plus h, then also it will be done in your favor. Okay, okay, all right. Oh, so now we have another question on our screen. Okay, so it is e minus 1 plus 2x upon x. Again, I will highly recommend check the form of it. 0 by 0 form is getting created. Let me show you how. So this is 1 raised to power infinity form, right? So if you solve this 1 raised to power infinity form, e raised to power, this power will come in front and you have to subtract 1 from the base. So 2x. So this is actually e. E minus e by 0. So 0 by 0 form. Okay. Now the moment you see na ki sometimes it happens that to check the form you have to like check, you have to, I mean to check the form you are not able to see the form directly. You have to apply the like logic of limits in order to calculate form of that limit. So for that what you need to do is use expansion. Okay, e minus, now this I will convert in terms of e because there is no other way. This you have to convert. You know that any number can be written down as e raised to power ln n. So this is how we are going to do that. E raised to power ln 1 plus 2x power 1 by 2x. Okay, this power 1 by 2x will come in front. E minus e power 1 by 2x ln 1 plus 2x. Okay, upon x is already there. So this is how your numerator, I am only talking about numerator. So now can you see your numerator is two different exponential. Okay, so from here what you need to do is, if you have two different exponential, I have already told you that you take one e common. So now your expression, let me just write down limit x tend to 0, right? And then you are having e raised to power 1 minus this. So I am taking e common because the next other thing is complicated. Take e common and rather minus e if you take common. No? So it will become what? Minus e if you take common. This will become minus 1, the very first thing. Minus 1 I'm going to write over here. And this is e raised to power 1 by 2x ln 1 plus 2x minus 1. Okay. So you are taking, again, the same logic. If you are taking some exponent common, then you have to apply minus sign. Same logic. E square is there. If you want to take e raised to power x common from that, so e raised to power x, e raised to power 2 minus x. Right? So if I am taking e raised to power 1 common from this, so I need to apply e raised to power minus 1 over here. Okay? Upon x. Now, you know that we are talking about the standard limit. Okay? E raised to power something minus 1 upon same something is 1. So, e raised to power this thing which is in green circle, this is what I will multiply and divide. So, this is 1 plus 2x minus 1. Division and multiplication. है ना? 2x and this is minus 1. Please understand this 2x is only with log, not with minus 1. So now this thing will become 1. And e raised to power same thing upon same thing will become 1. So now I'll be left with limit x tend to 0 minus e upon x is already there. And now we are having 1 upon 2x log of 1 plus 2x bracket close and minus 1. Now we have to use the expansion. Okay, this is a little bit difficult question. Now the final step is expansion, and you know what is the expansion of log of x, 1 plus x. So that is x minus x square by 2 plus x cube by 3. There are no factorials involved. So now log 1 plus 2x expansion I am going to use. So this is minus e by x, 1 plus 2x. So 2x minus 2x whole square by 2 plus 2x whole cube by 3 minus and so on, always happening, and upon 2x minus 1 I hope that this is visible. Okay. Clear? Okay. Now 2x upon 2x. This 2x and this 2x is gone. This is minus e by x is sitting outside. 2x upon 2x is 1 and 1 minus 1 is 0. So basically 1 minus 2x upon 2 plus 2x square upon 3 and all the way up to this is minus 1. Because 2x I have dissolved. 1 cancel. These terms can be neglected. X and x is getting cancelled. 2 and 2 is getting cancelled. So minus e into minus 1. Can you see? Minus e into minus 1 will give you plus e over here. So option C is absolutely right. Okay. So we are done with all the questions of the chapter limits, and I have to make a very important announcement that if you want to solve more PYQs, and you have to solve more PYQs, 220, 2023, 2022 and all previous year PYQs, do check out the Tattva series by Vedantu. Okay, link is already given in the description box. You will find very good collection of all the PYQs, previous year questions, in this Tattva series, and that will be actually more than enough if you solve last 5 years PYQs, but with utmost dedication, alertness, and good solutions also you will need, right? So with the help of short tricks, good solutions, you are able to solve it, then this is more than enough. And yeah, so link is given in the description box. And if you want to reach out to me, I am available on Telegram. You can ask any doubts if you have. So t.me slash, this slash or that slash, that you need to check. T.me slash namrata.jasinghani. This is my Telegram ID. So you can just ping me on this Telegram ID also. And yeah, so do check out the link which is given in the description box for Tattva. Also, comment that next which chapter you want to see in the PYQ series, so that I will record and upload that video also. This is me, Namrata, signing off. I'll see you all in next video.